there was an echo on the other system, but at least we are okay now with the echo. What I wanted to show you is the simulation. I'm going to show you the simulation on our experiment. If you encounter the same problem I encountered in my laptop, please follow the instruction on the link I'll send. I'll send you another instruction on, just in case somebody is not here and they will try to play and it's not working. There is another link where you can play without chaffer and still do the simulation. Let us see, this is, maybe I should walk you through, maybe just this one loaded without showing you exactly where to go or how did I end up there? How did I end up there? If you look at the top right here, this is where we're gonna get started. If you try to download from here, if it fails, there is another instruction, I'll send it to you. This is where you will do the simulation right here. You go to the rate of reaction here. This is where you'll go. And the direction called for, once you are in here, you'll download the chaffer, which will play. I want you to look at the direction on what it says on experiment number 4. Experiment number 4, right here. You have to follow step by step right here. You on the left, all right. If you look at here on the left, we are now downloaded. This is where we are. You see this? On the top left, you will see 3 tabs. It's a slot issue for you to mark single collision, many collision rate experiment. So where are those? There is single collision, there is many collision, there is, we got to go to where? You will have to check on single rate. Once you're here, this is what you need to enable. You want to go to the rate experiment. Initially, when you load, it was like that. You have to go to the rate experiment from the, this is where you need to go. There are 3, this and that, this is where you need to go. Select the experiment tab. This is the experiment tab being mentioned in the procedure. Now, you will change, if you look at the concentration, all right, there is the initial box, current box. In order to do the check the box option here, before you start the reaction, you need, this is where you're gonna check, you got to bring the experiment, or you can use your stopwatch. I'm just gonna check that. It's the experiment you're gonna need to use to measure the time. The time for what? Time for recording, or you will record here. This is trial 1, trial 2, trial 3. This is the average time. This is where you will gonna record time. You can use your cell phone to record the time. Doesn't really matter. But once you are in the experiment, I will check this and probably check this. These 2 right here. Upon checking the stopwatch, it will load the stopwatch on this side. All right. These 2 strip will load this. If you see, if I uncheck this, stopwatch will disappear. If I remove this none, you see this window will disappear. So if I go here, stopwatch, and this is what you need. Let's go to the direction. And what does the direction say? Right here. we will, to get the rate of reaction, we will want to get the change in number of molecules per unit time, which is molecules over what? Over time. This is what you will record. This is the average time you will be using. So how are you going to get it started with the experiment? For part A, when you are ready to begin the experiment, first of all, you need to set up the initial concentration. For initial concentration of A should be 10, and the initial concentration of B should be 100. Initial concentration, initial condition. This is where you will need for concentration of B, change that to 100. This is 10. Initial condition. For A, 10, for PC, 100. Let's see. Once you have that, you are ready to begin, okay? When you are ready, you can click begin experiment pattern there in the initial box, the way you will do, for 5. When the number of molecules of C, look at molecules of C here, reaches 5 in the current amount box in the middle, this is when you will now stop. All right. You will just click begin the experiment when the 5 in the current box. You will end the experiment. So this is, let me just start that. What you are giving an eye here is current amount. You see current amount, this is the C being mentioned. This is the C being mentioned, right? Once you see this value is 5. Once you see this value is 5. Right now it is 0, I have 10, I have 100. So what I have realized that is the stopwatch doesn't start right away. So you have to start both of them, it doesn't start by one click. If I click here, the stopwatch will not start. So I'll start begin and then start the stopwatch. The experiment is going on. This is where we need to keep an eye on. This is where we need to keep an eye on. It will change. You see it's changing to 2. It will change to what? It will change to 3. I should be ready here to end the experiment. If I end the experiment, you will see the stopwatch ending. So not yet, not yet. It's at 3 right now. It's at 3 right now. All right, it's at 3 right now. I'm just waiting for it to get to 5. The direction says you should wait until it gets to 5, and then you end the experiment. It's at 4 now, so I'm just waiting to get to what? 5. Yes, I stopped the experiment. You notice that when I click end, the stopwatch on the lower side of the screen stop as well. That is what you will record in the data sheet for experiment number 1 here. So I'm gonna record what it is 1475. So it's just 1475 here. This is when the concentration of A is at 10. That is what is meant here by current amount box. No, part A. I'm just in A right here. The stopwatch, you'll have recorded the number of seconds. Record this number under A10 category in the data sheet, then hit reset. So I'm gonna reset and do it again. You will reset it, reset right here. Watch what will happen if I reset. Say reset all, it will reset the stopwatch, and I'm gonna put that, and then I'm just gonna do the same thing again. 10 and maybe 100. All right, and then I just say everything is set. All right, begin the experiment. No, it didn't work. Hold on. My stopwatch. Reset this. I forgot to reset the stopwatch down here. Reset all, yeah. So the stopwatch is reset. All right, let's see. You have to do the same thing again, 100, and then begin the experiment. Yeah, you should start the stopwatch fast. It doesn't work. So I have to reset it again. It should be the stopwatch fast. 0 and then 100. So this is what you want to do. Begin and then begin again on the stopwatch. The stopwatch right here is, start. So once this one start, you also start the stopwatch. You start this and then start that at the same time. Let me repeat again. End the experiment, reset all, yes. Show the stopwatch on this side. I'm just gonna put it 110. You have to start, begin, and then start at the same time. Begin, start, begin, start. So you have to click begin and then start on this side. You have to do it every time you click begin, you click start. You begin, you click start. You'll do the same thing for changing the concentration of PC while keeping the concentration of A constant. So let's see, this is 3 right here. It's 4 right now. Stop. So this is the time. You see the time given here? No, I stopped. My apologies. It should be 5. Should be 5. Let me start over again so that you see how until you get it 10 and then 100. Let me show the stopwatch and then have that. So if I want to start again, this is 10, this is 100. You have to click this and click that at the same time. So I'm gonna do this, begin and start. There is a graph right here, so begin and start. I'll wait for this to read 5 before I click stop. Last time I did 4, which was bad. Keep an eye on C here. It is at 3 right now. It's at 4 right now, so I should be ready. 5, yes, I stop. This is the stopwatch. I will, this is the time on the stopwatch I'll record on the data sheet, right here. So you'll be doing the same thing over and over. Write this in part A, B right here. Do 9 more correct trials, all right, just in case, and then you find once you have 10 good trials, you can move to part P. So there is trial 1, trial 2, trial 3. You'll find the average average time. So time it takes, and then change in concentration. It's the number of moles. You're gonna read that rate. It is the change. You're gonna see the calculation. So it's not hard for part A. For part B, you will change the concentration. What does this mean? What does this mean? For this column right here, you will increase the concentration this time round. So I'm just gonna increase the concentration here to 20. Let me reset all, it should be reset all. And then I put here 20 and put here what, 100. Bring back my stopwatch right there. I have my stopwatch here. I have changed the concentration of A to 20. This remains at 100. and then begin the experiment and start the stopwatch at the same time. So I'm waiting for this number to reach to 5 before I end. It's just right here. I'm ready. Stop, stop, stop. Stop, yes, right. Oh, I messed it up. You got to repeat again. It shouldn't go to 6. Oh, they say it can go to 6, right? Is 6 good? I think they say 6 is good. I say at least because occasionally if you shoot to right past 5 to 6, all right, yeah. But aim at 5, aim at 5. So I'm gonna put the number here for concentration of A increase to 10. This is the concentration. To get this rate right here, you see the rate right here, how are you going to find here? I know this is easy. And please show me the calculation. How do you end up with the value here? You can use a scratch paper, use your calculator, key in that 1450 plus 650 plus 780 plus 1190 equals to this, and then you divide by 10 to get this average number. How are you going to get the rate? This value here is obtained by using this equation. Using this equation here, there is this equation right here. Change in concentration. We have the concentration already. You know the concentration already of A. All right, at that particular time, you're gonna use that concentration to find the rate of a change in time. You will flip the numbers now. You'll repeat the same experiment for PC and PC increasing the concentration, but this time around for part P, the concentration of A is 100. It is 100 for part P, and use the method of initial rates to calculate the reaction orders. You will have experiment 1. This is the same as experiment 1, experiment 2, experiment 3, experiment 4. With each rate, all right? So with each rate, experiment 1, all right, with each rate you will be able, you should be able to find the rate, the reaction order with respect to A, with respect to B, with respect to B. You got to show the calculation. That's all you have to do in this lab. Just wait the simulation. And I didn't ask you to find the rate constant. All I want to do, or I want you to do, is find the rate reaction orders with respect to A and PC. All right. The data sheet is due next week, all right, due next week. If you haven't received your lab kit yet, please let me know and we will work together. I know some folks are still waiting for the lab kit to arrive. If there is no other question, I will end our pre-lab lecture today here. If there is no other question, you are free to leave. We will meet next week, same time. Please work on the quizzes. And if you have any question, you can send me an email. I can schedule a Zoom session. I apologize for the glitches we encountered this afternoon. One, the tuning in, and I was in the other session as well. I'll see you next week. The session is ending. Thank you. See you next week.